So it turns out that we can test to see both individually and jointly if the independent variables are, if there's a relationship, a linear relationship between the independent and the dependent variables. So really what we're doing is we're testing to see if that beta coefficient is different or greater than or less than whatever hypothesized value we take. Now normally our hypothesized value is 0, so we're testing two-tailed test. Our null is that they are equal, and our alternative is that they are not equal. Of course, we can also test if they are greater than or less than also. Now, the test statistic for individual significance is the t-test, and we actually looked at that earlier back in the second video when we looked at the p-value of that t-statistic for the unemployment coefficient. So we'll go back and look at that in just a minute. Now we don't have to calculate the t-statistic because the Excel package gives that to us. Now, again, almost all statistical, sorry, it's a Friday when I'm recording this and words are hard on Friday. Almost all statistical software packages will give us the test statistic of t and the p-value so that we don't actually have to calculate it. And then we can use those p-values to determine, based on a two-tailed test, whether the coefficient is different from 0. If we're wanting to conduct a one-tailed test, then the computer programs, the statistical packages, don't give us that value, but we can divide p in half to compute a one-tailed test. Now, if we're wanting to test whether the coefficient is different from 0, like whether it's, greater than or equal to 5 or something like that, then we have to compute a new test statistic. So here's a sample of our regression data, or that regression analysis that we've used in Excel. I'm not going to jump to Excel. We're just going to pull it out and look at it here. We're looking at Model 2, where we used both income and unemployment. So we can see the t-statistic here, and then we can see the p-values. So we've already looked at these p-values, and we determined that for income, the p-value is less than 0.05. So we could reject the null hypothesis that that was not equal to 0. For unemployment, though, the p-value is much, much, much greater than 0.05, so we cannot reject the null hypothesis. So if you think about, if we're testing whether beta is equal to 0, if beta is equal to 0, then that tells us that it has no influence, no effect on the equation, on the dependent variable. So this would tell us if we got a coefficient of exactly 0, that it would tell us that, hey, unemployment or whatever the coefficient was has 0 impact on our dependent variable, in this case, debt payments. Now here we have a coefficient that is not equal to 0, but based on the t-statistic and the p-value, and again, you can't really just look at the coefficient and say, well, 0.6 is really close to 0, because depending on how the data is given to us, 0.6 could be very, very, very large, just depending on what kind of data that we have. So again, that's why it's important to not look at the raw coefficient, but to look at the t-stat and the p-value and say, well, we definitely cannot reject the null hypothesis with any level of confidence, 1%, 5%, or 10%. So we cannot reject the null hypothesis that unemployment's effect on debt payments is 0. So we would want to drop unemployment out of our regression analysis because it presumably does not have a statistically significant effect on our dependent variable. Now, we can test our variables jointly. And so what is their combined joint effect? And so for that, we're going to use what's called an F statistic. So we're testing whether income and unemployment together are significant in predicting debt payments. Now, the alternative is that at least one is not equal to 0, meaning at least one of the coefficients is predictive. So it's not saying that all of them are, just that at least one is. So here's the test statistic, the F statistic, and we've looked at this one before when we were in chapter 11 and we looked at that chi-squared test. But the statistical software packages do give us the F statistic and the p-value. So let's look at here in Excel. It's over there in the ANOVA section, so kind of the middle section there of what the regression data is given to us. And we see the F statistic is 34.995. And its p-value, which they call significance F. So significance F is the p-value of that F test. So the p-value is 1.05 e times 10 to the negative 7. So definitely it is significant. Now we already know that unemployment is not significant. So this is telling us, well, hey, unemployment and income together are significant, but we know from the individual that unemployment by itself is not statistic. It's not significant. We also know because in the previous example, when we did the goodness of fit test, we determined that model 1, which just uses income and not unemployment, was a better fit. So even though this model isn't bad, it's not the best one. Income without unemployment is a better model because unemployment is really not contributing anything significantly, statistically significant to our analysis.